All right. Hello, everybody. Okay, so we're going to get started on our next lesson here for Algebra 2. What we're going to be working on today is how to graph inequalities, linear inequalities. Later on, we'll talk about graphing things that are not linear, but for today's lesson, we'll start with graphing linear inequalities. I'll do another video for you guys on how to solve a system of linear inequalities, which is a slightly different problem. It's ultimately what we're working towards, but we'll talk about that in another video. First thing I would like you guys to do, I would like you guys to find the solution of this system. So go ahead and you can do this using any method. You can do this by substitution or elimination. I'm going to ask you not to do it by graphing. Let me give you guys a little more room here. I'll print out this for you guys so that you guys have some room to do this. Back all of this up here just a little bit. That'll work. Okay, cool. Give you guys a little bit of space here where you guys can do this. So here in the space here, go ahead and try to solve this using substitution or elimination. Go ahead and pause the video until you guys have worked out the answer. All right, you guys should have gotten for your answer 0, -2. If you did not get that for your answer, bring it up in class and we'll talk about it there. I don't want to show you guys the step here because I would like you guys to do this particular warm-up on a separate sheet of paper, and you will turn it into me next class period, and I'll give you guys a little bit of credit for this, just evidence that you guys are actually watching the videos and following the directions that I've laid within the video. So whatever this warm-up is, whatever you do it on a separate sheet of paper and turn it into me next class, and I'll give you guys some credit for it. So let's go to the next page of the packet and take a look at what we've got here. So we're going to be looking at graphing linear inequalities. The first thing we need to do for this particular example here is we need to be able to graph a line to begin with. Okay, so let's walk through our steps of that. Again, we have a couple of different ways of doing this. One way you can do this is you can recognize that -3 is going to be the y-intercept. So you have the point 0, -3, which you can put here on your graph. So 0, -3, if you guys can see this here, I'm hovering over it. 0, -3 is going to be this point here. And then we have a slope of +1/2. So that means that we will run once, because it's rise over run, so we go up 1/2, up 1/2. So from 0, 3, up 1/2, up 1/2. I'll do this in Desmos so you guys can see it. Use some graph paper and go ahead and graph this line. Y is equal to 1/2 x minus 3. When you do that, you should end up with a graph that looks like this. Oh, I said that wrong. I'm sorry. Did I click the right one? Yes, I did. Okay. So I made a mistake there. I said +3. The actual y-intercept is 0, -3. -3 is going to be this point right here. Let me zoom out just a tiny, or zoom in a little bit so you guys can see it cross that point here. So each one of the points here on my graph is 1. So here's -1, -2, -3, where I cross the y-axis. Our rise over run, our slope is 1/2. So we go up 1/2. Up 1/2, up 1/2, so on and so forth, and you can mark points every time you move up. Connect the dots, and you'll end up with your line. Alternatively, you can also just pick a couple of x values, so you could use like x is equal to 2. Plug that in here. 1/2 of 2 is 1, so 1 minus 3 is -2, so if I go over to 2, and then 2, so we had 1 minus 3, that's -2, so that gives us the point 2, -2, which happens to have a point at it. So there's a couple of different ways you guys can go about doing this. You can plot points, or you can mark the y-intercept, and then go up 1/2 using the staircase method. All right, so let's go back to our second page here. So how would we graph, how would the graph change if it was an inequality? For example, so we have the same equation here. Well, it's not an equation. We have this inequality, which is actually just this equation, but instead of having an equal sign, we have a greater than or equals to sign here. So here's the thought I want you guys to think about here. This function, or I'm sorry, this line, y is equal to 1/2 x minus 3, this is the collection of all points x and y that satisfy this equation. When we put all of those together, we end up with a straight line. So any one of these intersection points that we find here, actually any point on this line, is going to represent two numbers, an x value and a y value, that satisfy this equation and thus generate this line. The inequality, though, is saying we're looking for all of the pairs x and y such that y will be greater than 1/2 x minus 3. So another way of thinking of this is the line equal to 1/2 x minus 3. This is the collection of points above this line, or the collection of points greater than or equal to this line. So if we go back to our graph here, we have this line, or if you guys look on your graph paper, so we have this line. All the points that are greater than this line, and think about greater than this line. Is that going to be, are points greater than this line going to be above the line or below the line? Okay, they will be above the line. So everything that's greater than this will be above the line. And the way that we represent that is by shading in this area above the line after we have drawn it. So if I change this equal sign to a greater than or equal to, it will automatically shade in everything that's above the line that I graphed initially. Okay, so you guys can go ahead and do that on your sheet, on your graph paper. Okay, so that is the graph of an inequality. We graph the line. Your first step is to graph the line using whatever method you want, whether you start with the start with the y-intercept and then use the staircase method, or if you plot a couple points and then draw a line through it. The next part is looking at this, the inequality, and determining if it's above, if you're shading above the line or below the line. Now we have some rules that go along with this. I want to point out to you guys. So if you go to the next page, we have kind of these rules broken down for us, and that is when we have strictly less than or strictly greater than, we're going to have a dashed broken line. So if we look at our previous example, we had greater than or equal to. Greater than or equal to, we use a solid line. So it looks just like what we have here. If this was strictly greater than, though, we would have a dashed line. You guys will see here, if you look on the video, we have a dashed line now instead of a solid line. So when we have strictly greater than or strictly less than, we're going to use a dashed line. When it's greater than or equal to or less than or equal to, we will use a solid line. When we are talking about values less than a given line, we are going to shade below. When it's greater than, we shade above. So if we switch back to Desmos here we have graphed everything that is greater than the line. If I switch this to a less than, it shades everything that's below the line. Okay, so those are your general rules for this. If it's depending on whether it's strictly greater than or equal to, or less than or equal to, and strictly less than or equal to will determine whether you use a dashed line or a solid line. If you're dealing with less than, you will shade below the line. For greater than, you'll shade above the line. So let's do some practice of this. Let's go to the next page. On your graph paper, I would like you guys to graph each of these. Now I have these set up in Desmos, so I will show you guys what the final answer looks like. I'm not going to walk through the steps. The first thing you need to do is graph this like it's a line. So let me go back to Desmos here. We have y is less than or equal to negative 3/2 x plus 1. Our first step in this process is just graph the line. So we're going to graph that inequality, this inequality right here, just like it's a line. So we'll graph it as y is equal to negative 3/2 x plus 1, which looks like this orange line right here. Okay. The next thing we're going to do is now we're going to switch it back to less than or equal to. We go back to our inequality facts, or inequality rules here. For less than or equal to, we're going to shade below the line. Okay, so we will shade below the line that's been drawn here. And since it is less than or equal to, we're also going to have a solid line. So your final answer when you finish graphing this will be less than or equal to. So we have a solid line, and we will shade below the graph of the line. So this is above the graph of the line on this side, and this is below the graph on this side. Okay. All right, let's go to the next one now. So our next one is y is greater than or equal to 2x minus 4. So very quickly, your line should look like this. We're doing greater than, we're doing strictly greater than, so that will shade above the line, which is on this side, it's to the left. Okay, it's strictly greater than, so this will become a dashed line. So we'll change our equal here to a greater than. We end up shading on the left-hand side of the line. If you look here, we now have a dashed line representing our barrier, or our boundary. Okay, the very last one is x plus 3y is less than 6. for our purposes, I'm going to ask you guys to solve this and put it into y equals mx plus b form. So we will subtract x from both sides and then divide by 3. That'll give us a negative x over 3. Negative x over 3 plus 3 divided by 6 is 2. So we'll have negative x over 3 plus 2. Which looks like this when we graph it as a line. So negative x over 3 plus 2. Our inequality is strictly less than, so you should have y. When you guys solve this, you should have ended up with y is less than. So we will change this. Less than is going to be all these values below the line. It's strictly less than, so our line will become a dashed line. And will look like that. So shade below the line, and our line becomes dashed. All right, so let's go to our next page here. Another example for you guys. I'll ask you guys to do this one on your own. Okay, go ahead and solve it for y. I'll give you guys that much here. When you solve it for y, you will end up with. I'll do the math really quick here for you guys. I'm sorry, I don't have this prepared just yet. All right, so as a line, this will be y. I ended up with y is equal to 2 over 5x, and then the 5 divided by negative 5 is negative 1. So we ended up with y is equal to 2/5 x minus 1. But remember, this is an inequality we're working with here. We end up dividing by negative 5. When we divide by a negative or multiply by a negative, we switch the inequality. So the inequality we're really working with here is y greater than, strictly greater than, 2/5 x minus 1. Okay. So go ahead and graph that in the grid here. So we'll end up with, go over here, let's close this one out, and we're going to have y is equal to 2/5 x minus, where did I put this? Minus 1. There we go. Okay, so that's the line that I ended up with when I solved it, and it's going to be strictly greater than. Strictly greater than is going to make this a dashed line, and we're going to shade above the line. So we end up with that for our final answer on this one. All right. Okay. In summary, always get the equation in the form of y equals mx plus b. Remember your line, your rules here. So if it's strictly less than or strictly greater than, we're going to use a dashed or broken line. Greater than or equal to or less than or equal to, we use a solid line. Less than, we shade below the line. Greater than, we shade above the line. Okay, and then there's a little rule here that we can always check a point to make sure you shade it in the correct place. So actually, let's back up here and let's look at this one really quick here. So this is the last example we did here. So we had y greater than 2/5 x minus 1. So we're going to test points here. So a point that we pick that satisfies this should allow the inequality to be true. Okay, so if we pick a point that is below the line here, let's use the point, this is 5, negative 5. If we plug 5, negative 5 into this equation, let's look at what we end up with here. I'm going to be able to do this. Nope, I'm not. Hold on, let me get a text box here. We'll add this in here. Okay, so if we plug in a point here, if we plug in this point here, 5, negative 5, in for x and y, we will end up with 2 times 5. Ooh, that's really small. Let me make that bigger for you guys. There we go. So this will be 2 times 5 minus 5 times negative 5, okay, and then less than 5. And let's see if that works out to being a true statement. 2 times 5 is 10. Negative 5 times negative 5 is positive 25, so we end up with plus 25. Less than 5. We will simplify that. 10 plus 25 is 35, so we end up with a final statement of 35 is less than 5. Make this bigger so we can all read this easily. There we go. Okay, this is not a true statement. 35 is not less than 5, so we ended up with a false statement. So a point that is not part of our solution set would be down here, which makes sense. It's not part of our shaded in region. Let's look at this value here. Let's pick just a random value. Let's use the value 0, 5. Okay, so we'll plug in the value 0, 5 and see what we end up with. So 0, 5. So 0 and 5. Plug that value in. 2 times 0 is 0. Minus 5 times 5 is 25, less than 5, which simplifies into negative 25 is less than 5. That is a true statement. Negative numbers are always less than positive numbers. So negative 25 is less than 5 is true. So we've graphed everything correctly. All right, let's see what else we have here. So we're able to check our work here. We are going to say that's the end of this video. Our next video, we'll do the other half of this packet, and we'll talk about solving systems of inequalities by graphing, but that'll be in the next video. If I can get my video to stop recording. All right.